Here's a review of the volume of solids quiz. So here's the question. Number one, a chocolate store sells chocolate in two types of packaging. One package is a rectangular prism, which has dimensions of 10 by 16 by 13. And then the second package is a square pyramid, which has a side length of 13 centimeters and a height of 36. If both packages cost the same amount, which package of chocolate is the better buy? Explain your reasoning. So the volume of a rectangular prism is the length times the width times the height. So 16 times 10 times 13 is 2080 cubic centimeters. And then the volume of a square pyramid is 1/3 the length times the width times the height, or the area of the base, I should say. The area of the base times the height. So the area of the base is a 13 by 13 square times the height, and then 1/3 of that, or take the area of the base times the height and divide by 3, and you get 2,228. Let me say that again, 2,028 cubic centimeters. So the rectangular prism is the better buy because it has a larger volume. So you would get more candy in the rectangular prism. Question two, the cone has a volume of 240 cubic inches. What will the volume of the cylinder with the same radius and height? Explain your answer. So the volume of a cylinder will be 3 times as much as the cone based upon the formula. So here's the volume of a cylinder, and then the volume of a cone is right here. So notice everything would be the same if the height and the radius are the same. So if the height and the radius are the same, the cone is only 1/3 the volume of the cylinder. So the volume of the cylinder is 3 times as much as the volume of the cylinder is 3 times the volume of the cone. So therefore, if the cone is 240 cubic inches, then the cylinder would be 3 times 240, or 720 cubic inches. Oops. So which of the following containers will hold at least 500 cubic centimeters of fluid? So the way I did that problem is pi r squared h for the cylinder. So pi times 4 squared times 5 is 80 pi cubic centimeters, approximately 251.3 cubic centimeters. And then the triangular prism, the area of the base would be a triangle that's the base of the triangle is 20 and the height of the triangle is 8. So 1/2 20 times 8 is the area of the base times the height, which is 9, and you get 720 cubic centimeters. And then the triangular prism, the volume is 1/3 the area of the base, which is 22 times 9 times the perpendicular height, which is 10. So you don't need this. This is the distractor here. This is a slant height. You need the perpendicular height for that problem. So you look at these three answers, and which one is at least, which of these are at least 500 is B and C. So container B and container C. So a square pyramid with a base edge of 4 has a volume of 192. If the height is tripled, what will the volume of the new pyramid be? Well, you triple the height, it's going to triple the volume. Okay, and then if the base edge is doubled, so if the base edge is doubled, then the volume will increase by a factor of 4 because you're finding the area of the base. So that would be if it's a square pyramid, the area of the base is going to be 4 times as much if I double each dimension. So the volume is 4 times as much. A bowling ball has a radius of 7. What's its volume? So the volume formula for a sphere is 4/3 pi r cubed. And you get 132, let me say that again, 1,372 over 3 pi cubic centimeters. And if I multiply this all out on the calculator, it's 1,436.8 cubic centimeters. So just to illustrate that on the Desmos calculator, because you can use the Desmos calculator at home when you're at home. So if I go here and then this type in Desmos, and then desmos.com comes up. And if you see this tab right here, just go to start graphing. And here's a space where I can do the problem here. So the problem that I want to look at is right here. So 4/3 pi. So 4/3 times pi times 7 cubed. That's the problem I want to put on the Desmos calculator. So let's go back to the Desmos calculator for a second. So here it is. Here's the keyboard down here. And what we want to do is if you hit the divide key, it gives you a fraction par. So we want to put 4/3 as a fraction here. And then next to that, times. And pi. So if you look here, let me drag this out of the way. Here's the pi key. So times pi. And then times 7 cubed. So I hit this a to the b and then put 3 in the exponent. And then notice right here, here's my answer, 1,436.8 if I round to the tens place. So this is a good place to come for a calculator, especially if you want to use a pi key. Like on your phone, you can use that calculator, but there's probably no pi key on your phone's calculator. So go to Desmos, especially if you're doing volume problems that's using pi. Okay, so once again, you go to this keyboard. If it's hidden, then you just click on it and the keyboard will come up. And you can use these numbers and expressions here and use pi for volume problems. I'm going to go ahead and leave the Desmos calculator. Go back here. And I'm going to leave those couple problems off the review. So this is the review of the second quiz that we took. It was volume of solids. I'm going to go ahead and stop this video here. So if you want to retake the second quiz, you want to look at this video to help you with the retake.